Today we learn about mixtures and solubility. Before move to the main topic, mixtures, you have to recall the memory of matter. If you cannot remember this, you can watch it in another video, watch it in undergraduate science videos. The first part of this lesson, I would like to discuss the definition, the properties, the types and the classification of mixtures. In the second part, I would cover up the solubility of the mixture, factors affecting solubility in another video clip. It is understood that mixtures are also comes under matter. That means they occupies a mass and occupies a space. And also the mixtures are also having different states as it is a matter. As mentioned, pure substances can be divided into elements and compounds. This is a very simple explanation about elements. Elements are chemically the simplest substance and hence cannot be broken down using chemical reaction. If you want to know more about elements, please use the link given here. Here are given some examples of elements. And compounds also comes under pure substances and they are made out of two or more elements. Some examples are copper sulfate, sodium carbonate, distilled water, carbon dioxide, etc. Now move to the main topic, mixtures. First see the composition of a mixture. As mixtures are non-pure substances and are made up of two or more elements, example brass, and also mixture can be made up of elements and with compounds. By doing simple activities, you can understand about the mixtures. Please refer to page 30 in your textbook, activity 3.1.1. To conduct this activity, you are needed some hydrated copper sulfate crystals and mothballs, which are called, in chemical it is called as naphthalene and naphthalene. In single it is said as copper. By using a mortar and pestle, grind them separately, then you will see as in the picture. Hydrated copper sulfate in blue, mothball powder in white. Then mix them well. Then at a glance you will not be able to see the blue copper sulfate and white naphthalene powder separately. Instead you will get a mixture. Now you can say a mixture is a blend of two or more pure substances and each of the individual substances that forms is mixture. A mixture is called as components. In this activity, the components of this mixture are the copper sulfate and the naphthalene. In this activity, that is in the same page 3.1.2 activity, you have to use the same mixture which you have already prepared. Now put the mixture into a 100 ml beaker and add 50 ml of water into it. Stir it well, then take a funnel and insert the filter paper, then pour the solution into it. In this activity, you can observe some muddy-like substance will remain on the filter paper and blue solution will filter into the conical flask. What is remaining on the filter paper is called the residue. and what is being filtered is called as filter rate. If observe the residue by using a hand lens, you will be able to identify it as the mothball powder. This verifies that the components do not blend chemically and remain unchanged. And here you use a physical separating method. So we can say that mixtures can be separated into its components by using a physical method. Thus we can define the term mixture as a matter consisting with two or more components which are not chemically bound and that can be separated by using physical methods. And remember, these components should be mixed well. Now let's say, as mentioned, the mixture is consist with components. Let's see how these components distributed within the mixture. Are these components mixed and distributed equally, or whether there is any difference? To solve the problem, you have to do the activity 3.1.3 and 3.1.4. In the activity 3.1.4, you have to dissolve 100 grams of clay soil into a 500 milliliter water sample. Stir it well and keep 1 minute to stand still. Then using a cotton cloth, filter the muddy colored water into another beaker. This filtered water should be kept still at least 1 hour. Now look at the beaker. See the muddy color distributed in the beaker. The distribution of the muddy color in the beaker. What can you say? You will observe that the color distribution is not even. You will see the muddy color is dark towards the bottom and it is lighter towards the upper layer. Then take 2 drops of the solution, one from upper part and the other from the bottom. Place these two drops on a metal sheet and remember to mark them as A and B respectively. Then let it to evaporate. Then you will be able to see that more residue on the B spot which is taken from close to the bottom, so that you can conclude the amount of clay particles per unit volume is different from place to place in this solution, in this mixture. By keeping aside this activity, now move to the activity 3.1.4. Here you first prepare a salt solution by mixing 100 grams of salt with 200 milliliters of water. Stir well, let the salt dissolve thoroughly and filter it using a cloth as the previous activity. And keep the filtrate for 1 hour and take 2 drops from the filtrate as the above mentioned activity and let it to evaporate. Now see the residue. In this activity, you can observe there is a uniformity in the transparency and the dissolved salt particles also equal. This activity is concluded that there are variations in the mixtures. So we can divide the mixtures into two as homogeneous and as heterogeneous mixtures. So let's see the characteristics of the homogeneous mixtures or the homogeneous solutions. In a homogeneous mixture, the components cannot be observed separately from one another. Components are uniformly distributed throughout the solution. The physical properties such as color, transparency and density are identical in everywhere. Examples: salt solution, copper sulfate solution, sugar solution and brass. The characteristics of heterogeneous mixtures are the components can be distinguished from one place to another. The physical properties are not identical from place to place. Example: when clay is dissolved in water, when laundry glue is dissolved in water, cement mortar, sherbet drink, fruit salad, etc. As mixtures are also type of matter, as I mentioned earlier, we can get mixtures in all three states as matter behave. Therefore, we can classify all mixtures into four as the flow chart shown. Solid-solid mixtures, solid-liquid mixtures, liquid-liquid mixtures and gas-liquid mixtures. All these four types again divided into heterogeneous solid-solid, homogeneous solid-solid, homogeneous solid-liquid, heterogeneous solid-liquid, homogeneous liquid-liquid, heterogeneous liquid-liquid, homogeneous gas liquid, heterogeneous gas liquid. So now try to do the assignment given in page 35. Hope by watching this simple video clip you will be able to get a clear understanding about a mixture. Thank you.